welcome to my channel View Math. Now let's see a problem. If a, b, c are in continued proportion, show that a square plus b square by b into a plus c is equal to b into a plus c by b square plus c square. So what is given in this problem is a, b, c are in continued proportion they have given. So with this we are going to show that a square plus b square by b into a plus c is equal to b into a plus c by b square plus c square. This we are going to prove. So what is given? Given is a, b, c are in continued proportion. So if it is continued proportion, I can write a, b, c are in continued proportion they have given. Continued proportion. Continued proportion means I can write a, b, c as a is to b is equal to b is to c. Or otherwise I can write it as a by b is equal to b by c. So this is equal to some constant. So I am going to equate it to some constant k. So this implies what a by b is equal to k. A by b is equal to some constant k. So this can be written as a is equal to b k. I am bringing this b to the other side so it comes to the numerator. Similarly, b by c is equal to k. So what is given? B by c is equal to k. So this can be written as b is equal to ck. Now I am going to take the left hand side separately and right handed separately. I am going to substitute a is equal to bk and b is equal to ck, and then I am going to show that the left hand side is equal to right hand side. Now I am going to consider the left hand side first. Consider left hand side. So what is there in the left hand side? A square plus b square by b into a plus c. So this is equal to a square. A is bk. So I am going to substitute here. So a square is there. So if I substitute bk, it becomes b square k square plus b square divided by b is ck. Now I am going to substitute instead of b ck into a is bk. I am going to substitute bk plus c. This is equal to b, again b is there, b is nothing but ck. I am going to substitute it as ck. So b square, so it becomes c square k square, and already one k square is there. I am going to write k square plus b is ck, so c square k square divided by ck. Again b value is ck, so ck, already one k is there, so it becomes square plus c. So let me take the common terms in the numerator and denominator separately outside. So here in the numerator, c square k square and c square k square is common. Let me take it outside. C square k square. So in the first term, k square will be there inside the bracket plus c square k square. I have taken it outside, so plus 1. Similarly, in the denominator, c is common. Let me take it out, c outside. C square k into k square. I have taken one c outside, so k square. Again the c I have taken outside, so it becomes plus 1. Let me cancel the common terms on the numerator and denominator. So I will be getting k square plus 1 and k square plus 1 I can cancel. Again c square and c square I can cancel. Here k square is there, here k is there, so 1k and 2 gets cancelled. So the remaining term is k. So left hand side we have got this equal to k. Now I am going to consider the right hand side. Consider right hand side. Similarly I am going to proceed, and then I have to prove that right hand side is also equal to k, I have to show. Now consider the right hand side. Right hand side is b into a plus c divided by b square plus c square. So this is equal to b value, b is ck, I am going to substitute ck, a is bk plus c divided by b square is c square k square plus c square. So this is equal to ck, as it is I am writing. Here b is there, I am going to substitute for b, ck, and one more k already it is there. So it becomes c k square plus c divided by c square k square plus c square. Now let me take the common terms outside. Here in the numerator the common term is c, I am going to take it outside. So it becomes c square k into c, I have taken it outside. So inside the bracket I am getting k square plus 1. Denominator, c square is common, let me take c square outside. So k square plus 1. Let me cancel the common terms. K square plus 1 and k square plus 1 I can cancel. C square and c square I can cancel. Now I am getting it is equal to k. So I have got the left hand side is also equal to k and the right hand side is also equal to k. Hence we have proved. This implies left hand side is equal to right hand side, that is a square, that is a square plus b square by b into a plus c is equal to b into a plus c by b square plus c square. This we have proved, hence proved. Now let's see the next problem. If a, b, c are in continued proportion and a into b minus c is equal to 2b, prove that a minus c is equal to 2 into a plus b by a. So what is given in this problem is a, b, c are in continued proportion they have given. So what is given? Let me write first one. A, b, c are in continued proportion they have given. A, B, C are in continued proportion. So I can write A, B, C as A is to B is equal to B is to C. I can write this as, we know the product of the extremes, is equal to product of means. Product of extremes is A into C. So AC is equal to product of the means is B into B, that is B square. So I can write this as B square is equal to AC. So this is given. So from what is given, A, B, C are in continued proportion. So it is continued proportion means I can write B square is equal to AC, I can write. Next what is given is A into B minus C is equal to 2B. So the next thing given is A into B minus C is equal to 2B. This is also given. A into B minus C is equal to 2B. So let me multiply this A inside. I'll be getting AB minus AC is equal to 2B. We know that AC is equal to B square. So let me substitute AC as B square. I'll be getting it as AB minus AC is B square is equal to 2B. Now, here B is common, let me take it outside. A minus B, so I have taken B is common, I have taken it outside, so A minus B is equal to 2B. Now B is common on both the sides, so let me cancel B. B and B gets cancelled, so I'll be getting A minus B is equal to 2. Now I'm going to consider, now all these are given. From the given I have derived this. A minus B is equal to 2 and B square is equal to AC. So from the given condition I have got this. Now we have to prove. To prove what is given in the question is to prove A minus C is equal to 2 times A plus B by A. So this is the thing I have to prove. I'm going to consider the left hand side and then I'm going to prove it is equal to 2 into A plus B by A. Proof A minus C. I'm going to have considered the left hand side. A minus, consider A minus C. Now in order to prove it is equal to 2A plus B by A, what I'm going to do is I'm going to multiply the numerator and denominator by A. So I have multiplied the numerator and denominator by A. So now this is equal to, let me multiply this A inside the bracket. So I'll be getting A into A is A square minus AC by A. We know that AC is equal to B. So I'm going to substitute instead of AC as B square here. AC is equal to B square. So A square minus AC is B square by A. Now this is equal to, now I can write A square minus B square as A minus B into A plus B. I have used the formula. A minus B into A plus B by A. Now we have got A minus B is equal to 2. This is also from the given condition. We have got A minus B is equal to 2. So here instead of A minus B I can substitute 2. So 2A plus B by A. So we have proved it. A minus C is equal to 2 times A plus B by A. Hence proved. Now let's see the next problem. If A by B is equal to C by D, show that A cube C plus AC cube by B cube D plus BD cube is equal to A plus C the whole power 4 by B plus D the whole power 4. So what is given is A by B is equal to C by D is given. A by B is equal to C by D they have given. So that means A, B, C, D are proportional. So let me equate this to some constant K. So now what happened is A by B is equal to K. A by B is equal to K. So this from this I can write A is equal to BK. Again C by D is equal to K. So this implies C is equal to dk. Now I am going to consider the left hand side separately and the right hand side separately, and then I have going to prove that left hand side is equal to right hand side. Now consider the left hand side. First I am going to consider the left hand side. Consider left hand side. A cube C plus AC cube by B cube D plus BD cube. Now I am going to substitute here A and C as A as BK and C as DK. Now A cube, so A cube is A is BK, so now B cube, K cube, C is DK, so DK plus A is BK. Again now C is dk, so C cube is there, so it becomes d cube k cube by denominator as it is. I'm going to write b cube d plus bd cube. So in the numerator, whatever is common, I'm going to take it outside here. K cube k, that means k power 4 is here, and here also k power 4 is common. So let me take k power 4 outside, k power 4. So I'll be getting b cube d inside the bracket, b cube d plus, here the second term I'm getting bd cube, bd cube divided by b cube d plus bd cube. Now I can see in the numerator and denominator b cube d plus bd cube is common, so I can cancel these two terms. I will be getting k power 4. Now I am going to consider the right hand side. Consider right hand side. Right hand side is a plus c the whole power 4 by b plus d the whole power 4. So this is equal to, a value I am going to substitute. So a is bk and c is dk the whole power 4 divided by b plus d the whole power 4. So this is equal to, in the numerator I can see K is common, I am taking it outside. If I take outside the bracket, it comes with the power 4. So K power 4 B plus D divided by B plus D the whole power 4 divided by B plus D the whole power 4. So this is equal to, now b plus d the whole power 4 is common in the numerator and denominator. I am going to cancel this. So I'll be getting, it is equal to k power 4. So now we have proved that the left hand side is equal to k power 4 and the right hand side is equal to k power 4. So left hand side is equal to right hand side. Therefore left hand side is equal to right hand side. We have proved that a cube c plus ac cube by b cube d plus bd cube is equal to a plus c the whole power 4 by b plus d the whole power 4. Hence proved. Now let's see the next problem. What least number must be added to each of the numbers 6, 15, 20 and 43 to make them proportional? So we have to find out the least number which is being added to these numbers, and then it is made to be proportional. So let the least number be, let the least number be x. So this x is being added to each of these terms and then it is made to be proportional. So 6 plus x. So I am adding this number 6 plus x is to, then we are making it a proportional. Okay. So 15 plus x. X is being added to 15, which is equal to 20 plus x is to 43 plus x. So I'm adding this least number x to each of these terms and then I'm making it to be proportional. So now we know the product of the extremes is equal to product of the means. So product of the extremes is 6 plus x into extreme. This is 43 plus x, product of the means. So I'm going to multiply these two terms. I'll be getting it as 15 plus x into 20 plus x. Now let me simplify this to find out the value of x. Now 4 into 43 is 258 plus 6 into x is 6x plus 43 into x is 43x plus x square. This is equal to 15 into 20 is 300 plus 15 into x is 15x plus x into 20 is 20x plus x square. Now I can see x square term is common. Let me cancel. I'll be getting here 49x. If I add these two terms, it is 49x plus 258. This is equal to 15x plus 20x is 35x plus 300. Now let me bring this 35x to the left hand side. I'll be getting it as 49x minus 35x, which is equal to 300 minus, I'm bringing 258 to the right hand side, so negative 258. 49x minus 35x is 14x is equal to 300 minus 258 is 42. X is equal to 42 by 14. X is equal to 14 one times and 42 3 times. So x is equal to 3. So we have found out the value of x. The least term which is being added is x is equal to 3. Now let's see the next problem. What least number be subtracted from each of the numbers 7, 17 and 47 so that the remainder are in continued proportion? So what is given is solution. What least number be subtracted from each of the numbers? So some number, a least number is being subtracted from each of these numbers 7, 17 and 47. After subtracting the least number, that number, that means the remainders, that number are in continued proportion they have given. So what is given is some number, a least number is being subtracted. So that number only they are asking us to find out. So let me take the least number to be some x. The least number, let the least number subtracted from each of the numbers be x. So let me take the number to be x. So after subtracting, we will be getting 7 minus x, 17 minus x, that means 7 minus x, 17 minus x and 47 minus x. So these numbers are in continued proportion they have given. So continued proportion means we'll be writing it as 7 minus x is to are in continued proportion. 17 minus x is equal to 17 minus x is to 47 minus x. So we can write this as product of the means is equal to product of the extremes. Then minus x into 47 minus x is equal to 17 minus x the whole square. Now let me multiply. 7 into 47 is 329 minus 7x minus x into 47, so minus 47x, minus into minus becomes plus, x into x is x square. This is equal to 17 minus x the whole square, so I can apply the formula a minus b the whole square is equal to a square plus b square minus 2ab. I am going to apply this formula here. 17 the whole square, I'll be getting it as 289 plus x square, that is b square, minus 2 into a into b. 2 into 17 is 34b. 34 here, instead of b I'll be getting it as x. 34x. Now 329, let me bring this 289 to the left hand side, minus 289, this is equal to, now here x square term is common, I can cancel on both the sides. Now x term, I'm going to bring it to the other side, I'll be getting it as 7x plus 47x minus 34x. 329 minus 289 is 40 is equal to, here 7x plus 37x minus 34, I'll be getting it as 20x. Now 40 by 20 is equal to x. So 21 times 20, 2 times, therefore x is equal to 2. So we have found out the least number which is being subtracted is x is equal to 2.